When I was a kid, one of my favorite types of books to read were called choose-your-own-adventure stories. The books would make you the main character of the story, and after reading a few pages, they would ask you a question about what you wanted to do next. Depending on which choice you made, you'd go to some particular page and keep reading from there. Then you'd encounter another question, and so on. You could read these books over and over, making different choices, and get a totally different story each time. Until now, our computer programs have been like reading a book straight through from beginning to end. We have instructions in order, one after the other. You perform command 1, then command 2, then 3, and so on. Now, we're going to see how to make choose-your-own-adventure computer programs. We'll get to make choices about what to do, and this will make our programs and the things we can do with them a whole lot more interesting. We're going to introduce a new type of computer command, the conditional. A conditional lets us make a decision about which option to choose. We'll have a clear basis for making that decision, a way to know which choice is the right one. And depending on that choice, different things will happen. Another term we use for this is branching. Our computer code is going to have different branches, and as we walk through our code, we're going to encounter points at which we have to decide which branch to follow. Let's start with a simple example that's easily expressed with conditionals. Say a computer-controlled thermostat needs to decide whether or not to turn on the heat. It will have some criteria, usually whether the temperature is above or below some minimum. If it's below, it'll turn on the heater, and if not, it won't. Here's what some code to implement that would look like. We'll see how this statement works in this lecture. Let's start with this short piece of code using a conditional statement, the if statement. We start the statement with the word if, and this tells us that we'll be having a condition. Right after the if, we have the condition itself. The condition is something that's either true or false. For right now, we're going to use the words true and false for our conditions, but in a few minutes, we'll talk about how to make them much more general. It's important that you understand this. I'm going to just be saying true and false right now, but we'll see in a minute that the condition is usually written as a much more complex expression that evaluates to be true or false. In this example, the one you see here, we'll have a condition that's just plain true, so we just use the word true. Notice that the T is capitalized. If the T in true were lowercase, it would just be a variable with the name true. In Python, it's common for a constant value to be capitalized. Since true is a constant value, meaning true, of course, it's capitalized. Okay, after the word true, we have a colon, indicating that now we're going to see what happens if the condition were true. After the line beginning with if, we have the result of what should happen if the condition is true. This is indented in from the if statement by 4 spaces. A tab is also possible, though that's not the Python standard method. Good editors like PyCharm will automatically convert your tabs to 4 spaces, but if you're writing your own code, say in a text editor, you should always be consistent about using 4 spaces. Now, in this case, we have a single print statement that should be executed if the condition were true. For the example, we'll print out a line of text saying, turning on the heater. Okay, so now that we've seen this line of code, what should we expect to happen when this actually executes on the computer? Well, we see an output saying, turning on the heater. What's happened here is that the computer comes to the statement, it evaluates the condition, which is true in this example, and since it's true, it follows the indented code. But what if the condition is false? Well, in this case, we won't execute the code that's indented, so there's nothing at all output. Let me encourage you to try coding something like this yourself right now. We're going to have a lot more examples coming up, and you'll probably understand them better if you try writing the code and testing it yourself as you follow along. So, go ahead and see whether you can write some code that will print out dangerous cholesterol levels if some condition is true. Say if we eat ham and jam a lot. Here's what that code might look like. See, pretty simple. We have an if statement, a condition, a colon, and then we indent the print statement. We have to indent. We have to indent because indentation is how we know, and how the computer knows, what to do if the conditional is true. That is, when you indent a line of code in Python, you are literally telling the computer where a new block of code begins. Alright, let's say that we want to print more than one line if the condition is true. We can indent a second line of code, in this case one that'll output it was too cold. When we execute this code, we have a true condition, and so we execute both lines of code, and we get 2 lines of output, turning on the heater, and it was too cold. Now, if the condition were false, we'd again have nothing output. Let's say that we didn't have the second print statement indented, that there's no tab, and it just lined up with the if. In this case, where the condition is true, we still get both lines output. But what if the condition were false? What do you think will happen here? Okay, in this case, the print statement, it was too cold, is not indented, so it's not part of the if statement. The computer comes along, sees the if statement, checks the condition, which is false, and skips the indented lines. Then it goes on to the next line of code, which is not indented, and it executes it. So, the statement printing "it was too cold" is executed. Alright, this code that we've been looking at is an example of an if statement, or an if-then statement. But sometimes we want even more from our conditionals. Suppose our thermostat's decision is a lot more complicated. For example, maybe it has a different minimum depending on the time of day. And maybe it also controls an air conditioner so that it turns on the air conditioner if you get above a maximum. Well, for this, we want an if-then-else statement. If-then-else statements have 2 sets of code that can be executed. One if the condition is true, and the other set if it's false. It's a simple idea, so let's look at an example. The syntax looks just like the if-then statement, but now we have another line, else, right afterward. Notice the colon also. We again have indented code right after that, saying what to do if the condition is false. So let's see what happens if this is executed. If the condition is true, only the first set of indented code is followed. So in this case, we have a true condition, and so we see the output turning on the heater. On the other hand, if the condition is false, we would follow the second set of indented code, the part after the else. So in this case, we see the output, temperature is fine. Okay, let's try another one. How would you create an if-then-else statement that either prints out dangerous cholesterol levels if a condition is true, or cholesterol levels seem okay if it's not? Here's what that would look like. Again, it's not too complicated. We've just added on the else line and an indented print statement after it. Okay, now let's make if-then-else slightly more complicated. We're going to introduce the idea of nesting. When we have indented code, it's just like the other code we have. The computer executes the commands that are indented just like it executes the first commands. That means that within the indented code, we can have another if-then-else statement. We call this nesting because one statement is entirely within the bounds of the other. You can think of the first if statement as being the nest, and the other if statement being inside the nest. And this can continue as long as we want. We can have an if statement inside of an if statement inside of an if statement, etc. We call the statement that encompasses the other one the outer statement, and we call the one that's nested inside the inner statement, or the nested statement. What if we insert another if statement within the first indented section? Looking at the code, we see that the inner if statement has its own indented code. In this case, where both conditions are true, as we execute the program, we would first output "it is cold," and then output "the heater is already on." The rest of the code would be skipped. Now, let's assume that the first condition was false. In this case, we'd skip the entire indented first section, including the nested if statement. We would go straight to the else portion of the outer statement. It wouldn't matter a bit whether the inner statement's if condition was true or false, because that line of code never gets reached. Okay, up until now, we've written our conditions as either true or false. But that assumes what we want the computer to find. If we know at the time we're writing the code whether it's true or false, we don't even need a condition. So, instead of writing true or false for the condition, we need a way for our condition to be something that can either have the value true or false. This value that can be either true or false is called a Boolean. A Boolean variable is a type of variable that can either be true or false. Suppose we have a Boolean variable, temp is low. Then our if statement, instead of saying if true, will say if temp is low. In the example you see, the output is still turning on the heater, whenever temp is low is true. On the other hand, if the value is false for temp is low, then our output would be temperature is fine. Any false conditional, however nonsensical, will have the same effect. Output would be temperature is fine. Now, conditionals are really only valuable when we don't know ahead of time whether the condition will be true or false. This means that we need to be able to take an expression and determine whether that expression is true or false. The most common way we do this is with comparisons. A comparison lets us compare two values. We can pick how we want to compare them. The easiest way to understand this will be to look at some examples. Let's define three variables, a, b, and c, and assign a the value 1 and both b and c the value 2. Then let's do some comparisons. If we check whether a is greater than b, we'll find that this is false, since 1 is not greater than 2. While if we compare whether a is less than b, it's true. The same thing happens if we use greater than or equal, and less than or equal as our comparisons. 1 is not greater than or equal to 2, but 1 is less than or equal to 2. Notice the syntax. The greater than sign always comes first, then the equal sign. The less than sign always comes first, then the equal sign. Let's see what happens if we compare b and c. b and c are equal. They both have the same value, 2. So, b greater than c and b less than c are false expressions. But when we also check for b greater than or equal to c, or b less than or equal to c, they're true. Now, let's look at two more comparisons, equal and not equal. Each of these has a special notation that you need to use that's probably a little different than non-programmers would expect. To compare for equality, we use a double equals sign. It's important to use a double equals for comparison. If you only use a single equals sign, that's an assignment. If you're wanting to compare whether or not a and b are equal, that's just an expression that can be true or false, but assigning b to a is a command. In Python, an expression and a command are different things. A command actually performs an action, such as assigning a value to a variable, while an expression is just something that gets evaluated to find a value. If you get an expression mixed up with a command or vice versa, the Python interpreter will usually catch this for you. In other languages, by the way, the line between expression and command is more blurry, and finding those mistakes can be a big headache. Okay, to compare for inequality, that is to check whether two things are not equal, we use an exclamation point followed by an equal sign. This comparison will be true when the two things being compared do not have the same value. As you can see, we can compare a and b, which have the values 1 and 2, for equality, and we get a false. Or we can compare them for inequality, and in that case we get true. If we compare b and c, which both have the value 2, then the equal comparison is true, and the not equal comparison is false. And remember, the single equal sign is not a comparison, it's an assignment. So writing a equal to b will actually give a the value 2 in this case. Now we're at a point where we can actually write some more interesting code. You've probably seen restaurants that advertise that kids 12 and under eat free. Let's say that we want to put this concept into code. We'll assume that we've already gotten someone's age, and we want to tell them whether or not their meal will cost anything. As you see in the code, we will use a comparison to determine whether or not the person's age is less than or equal to 12. Now, the first line probably looks a little confusing. Just to make things clearer, it helps to put in some parentheses. So, the code checks whether the person is 12 or under. If they are, then x will be true, and we'll tell them that the meal is free. If they're not, then x will be false, and we'll tell them they have to pay. Here's a tip. Now doing this comparison, assigning it to a variable, and then checking whether the variable is true or false is more work than we really need to do. Most of the time, we don't need to keep the value of the comparison around any longer than just checking it in the if statement. So, instead of assigning the comparison to the variable, we'll just put the comparison straight into the if statement. You can see an example here, which works exactly like the code we just saw. Instead of assigning something to x and then saying if x, we now just say, if age is less than or equal to 12. It's also a lot easier to understand this code, since we have the comparison right in the if statement so that it's easy to read. Previously, to understand the if statement, we'd first need to figure out what x was supposed to be. Let's look back at one of our earlier examples, the one where we illustrated nesting. Initially, we just had true and false as the conditions. Imagine that we had the current temperature stored in a variable called current temp, and we had a Boolean variable, heater is on, that's true if the heater is currently on and false otherwise. How might we write our condition? Well, for the first one, we might do a comparison, whether current temp is below some threshold, say 68 degrees, or not. For the second, we can use the heater is on variable to be our condition. Let's look at one more example, just a little bit more complicated. Look at the code here for a minute and see if you can figure out what it's doing. You can see that this code gives information about servicing a car. It first computes how long it's been since the last oil change and tire rotation. If it's been at least 3,000 miles since an oil change, it recommends an oil change and possibly also recommends rotating tires. If it's not time for an oil change, it just gives a message saying how long until the next oil change. Conditionals like these form the heart of many programs, including ones you encounter all the time. Now, you've probably visited websites where you enter information and the web page checks something for you. Maybe it makes sure that none of the required fields are blank, or maybe it checks your credit card number to see if it's valid, or maybe it checks an age or a birth date to see if you're eligible for something. The code underneath all those web pages is using conditionals, just like the ones you've seen here. Now, what if we wanted to form more complicated conditions? For instance, maybe we want to check whether the number a is between 1 and 10. That actually requires two checks. One to see whether it's greater than or equal to 1, and another to see whether it's less than or equal to 10. So what do? Look at this code. You'll see it does a check for a being between 1 and 10, but it's rather messy. We have to nest two if statements together. If both are true, then we print out that it's in range. But if either one is false, we print out that it's not in range. Since we've nested the if statements, we need to print out not in range in both else clauses. This doesn't seem very good, especially since we have a pretty simple condition we're checking for. So it turns out that we can combine conditions using some simple Boolean logic. The three Boolean operators we'll care about most are and, or, and not. We use the and operator when we want two things to both have to be true in order for an overall expression to be true. For instance, if I say, my name is John and the moon is made of green cheese, that would be a false statement overall. Although the first part is true, my name is indeed John, the second part is not, and so the overall statement is false. On the other hand, the or operator is used when you want the statement to be true if either of the two things, or both, is true. So, if I said, my name is John or the moon is made of green cheese, that's a true statement, since the first part of it was true. The third operator is not. You can put not in front of any Boolean to switch a false to a true, or vice versa. If I was speaking, this not would come in the middle. My name is not John. And that's turned the statement into a false one. In programming, though, we just have values, and so the not would come first. So we'd say, not my name is John. In code, we just use these words, all in lowercase, to combine Boolean values together to get new Booleans. We can chain lots of these together, but when we do so, it often helps to use parentheses to distinguish which parts are which. Let's look again at some simple examples with variables a, b, and c. The first statement combines a false statement, that a and b are equal, with a true one, that a and c are not equal, using an and. Since an and requires both parts to be true, this overall statement is false. The next statement is an or statement, and it combines two true statements. So, it's true, and in fact it would have still been true even if one part or the other was false, like we see in the third example. The fourth line shows the use of not. We've added parentheses to make it clear. Now, take a look at this example, which is quite a bit more complicated. Look at it for a while and see if you can figure out whether it's true or false. Well, if we look at the values for each of these statements and then combine them one by one, we can determine the answer. The first clause, A less than B, is true, since 1 is less than 2. The next one, B less than C, is false, since B and C are equal to each other. Then the last comparison, B equals C, is true. We can work through to get the answer just like we would for an algebra problem, but the choices here are much simpler. The not false becomes true, and the not true becomes false. The first part is true and true, which is true. And finally, we have true or false, which evaluates to true. So that first statement, complicated as it was actually a true statement. Now, usually, if you do find yourself with such a complicated comparison, you want to stop and think about whether it's really necessary. Most of the time, when I have a really complicated condition like that, I find that I've been thinking about it in a more complex way than's needed, and I can simplify it down to a much more manageable condition. Think about it. Whenever you have a condition, you must indent on the next line. So, if you don't combine your conditions with a Boolean, then they have to be nested. Let's see how this could be used in the example we saw earlier. Remember the check to see if variable a was in the range from 1 to 10? We had a set of nested if statements. If you think for a minute about what we've just seen, how could we simplify this so that we have just a single if statement? Well, you can see here that we can combine the conditions into a single condition using an AND. A greater than or equal to 1 and A less than or equal to 10. This makes our if statement much simpler in terms of code, and it's also much simpler in terms of understanding what's happening. We can see the entire condition on one line, rather than having to look at all the lines of nested ifs. Now, before we move on to some other topics, I want to show you one more thing about this statement. First, remember the code we've just been looking at where we're checking whether the variable is between 1 and 10? Notice that this alternative code does the exact same thing. If a is less than 1 or greater than 10, then we're out of range. Otherwise, we're in range. So does this code. Putting a not in there makes it more complicated, though. And even this one. Wow, I mean, this is a really complicated way of writing it. In this case, we check for numbers greater than 1 and less than 10 first, and then we check to see if it's equal to 1, then if it's equal to 10. Ugh! Well, my point in showing you 4 different ways to do the same thing is to make one key point. There can be lots of ways of writing code that does the same thing. Some of that code is simpler and easier to understand, but it all has the same effect. Writing code is not something where there's just one correct solution. The key to writing good code is to understand the range of options available and choose one that's clear and simple. When you write code, don't get bogged down in the idea that there's only one right answer. There are usually many right answers, and the one that's best is often just a matter of judgment. There's one more topic related to if-then statements that I want to talk with you about. Let's use an example that you might have run into if you buy a movie ticket, or visit an amusement park, or go eat at a buffet restaurant. Often, businesses will set different prices depending on age. Kids less than 3 might be free. There might be one price for kids 12 and under, and another for seniors 65 and older, and another price for everyone else. Let's see how we might set this up in code. If you look at the code here, you'll see we have a few if statements to handle these cases. First, we have the case to check for the youngest kids. Then, we check for the kids 12 and under. Then, we check to see if we have a senior. If not, we use the default price. Again, we could have written this in several different ways, but all of them would have been nested if statements. That's kind of a pain, especially if there are lots of cases. You can end up indenting your code halfway across the screen. Fortunately, there's an additional command that we can use to handle these cases, the elif statement, which is short for else if. When we have an else statement immediately followed by an if, we can use the elif to combine them together without having to indent further. So let's look at that last example and how elif can simplify it. Okay, here again is the set of nested if statements that we were just looking at. Now, take a look at this code, where we've used elif to handle the exact same cases. The code works the same way. It sets the same prices. All those elif statements are ways of identifying the various cases, and this way of writing it is a whole lot simpler and easier to understand. Anytime that you have an else-if combination, it's probably a lot clearer to combine these statements with the elif. Let's see one more example of how we could simplify with a Boolean. In the casino game Craps, a player rolls a pair of dice. If the roll is a 2, 3, or 12, the player loses. And if the result is a 7 or 11, the player wins. If any other number is rolled, that number is called the point, and the game continues. Here's an example of a set of if, else-if statements expressing this. How might we simplify this using Booleans? There's more than one way, but here's one option. We can combine the losing options into one check, the winning options into another, and the point options into a third. This is obviously more compact, and it's also easier to understand. Conditional statements let us write programs where we choose our own adventure. Our choices are based on comparisons and decisions made by if-then-else statements, which we sometimes write in the more compact form of elif statements. All these conditional statements are what allow us to get a huge variety of different outcomes. We can describe those choices by making comparisons between values, and we can make more complicated comparisons in conditionals by using Boolean operators, such as and, or, and not. Although there can be many different ways to achieve the same goal, we should try to use the simplest way of writing that we can. These conditional statements can form the basis for much of the complex behavior that a computer program can exhibit. Anytime you see a computer reacting differently depending on your action, there's almost always a conditional somewhere underneath. In the next lecture, we'll be looking at how to take some of these basic ideas we've discussed so far and put them together to make a larger program, one that'll help us evaluate savings. See you then. Here's an exercise to practice the conditional. Imagine that you're writing a routine to help a doctor identify potentially high cholesterol levels. You can assume that there are 3 variables to find: HDL, LDL, and tri, which stand for the 3 components of cholesterol: high-density lipoproteins, low-density lipoproteins, and triglycerides. You can get total cholesterol by summing up LDL, HDL, and 1/5 of triglycerides. Now the charts that you see show levels of each that are considered good, borderline, and bad. Just to be clear, this is an approximation, not medical advice. You want to output one of 3 messages. If a person is good in every category, you want to tell the doctor, cholesterol looks great. If any one category is bad, you want to tell the doctor, warning, cholesterol looks bad. And otherwise, you want to tell the doctor, borderline cholesterol problems. See if you can put together some code that will make this check. Pause, and once you've implemented this yourself, you can continue to see how I did it. Okay, what you see here is one possible way to implement that idea. It's not the only way to do it, so if you came up with something different, it's probably still okay. In our first line, we compute total cholesterol. We then have 3 checks. The first condition checks whether all 4 values are in the good range. If so, it outputs the cholesterol looks great line. The elif condition checks whether any one of the values is in the bad range. If so, it prints out the warning. And if neither of these is the case, we get to the else clause and we print out the borderline message. This is just one example of how a conditional can be used to help sort out and choose from one of several outcomes.